3.8 Transformations of Functions. All right, so before we get started, I'm just going to go over a couple different things. So this is called the vertex form, which you use when you're dealing with a parabola. So you have a times x minus h squared plus k. So h and k actually stand for the vertex point that is the center of your parabola. So when you have a parabola that looks like a U, at the bottom you'll have a point where it starts to turn. This is decreasing, and all of a sudden it starts to go back up the other side. So where it starts to go back up the other side, the point at which it starts to turn, that's called the vertex. So this is called the vertex form, and the reason why this is useful is because when you put the quadratic into the vertex form, you can immediately identify h and k, which is the point that the vertex is at. So I'm going to explain to you what that looks like later. I know that might sound confusing, but you'll understand as soon as I show you. So a few things about vertex form. Actually, the number that's right here will tell you how big, how tall, or how short your parabola is going to be. So the bigger the number, the taller it's going to be, and it's going to be very thin. The smaller the number, it's actually going to be very short and wide. And then it also tells you if it's upside down or right side up. So right side up looks like a U, and upside down looks like an N without the little, tail on the left side. So if it's negative, it's going to be upside down, and if it's positive, then it's going to be right side up. So it's going to look like a U if it's positive, and it's going to look like an N if it's negative. Then your H in here, whatever this number is, will tell you how many units to the left or to the right that it's going to move. And if it's minus a number, it's going to be shifted to the right. If it's adding a number, it's going to be shifted to the left. And I'm going to give you a little acronym, which is kind of like a mnemonic device that will help you remember which one's which. And then K, remember, is your Y of your vertex. So that's going to tell you how many units you're going up or down. So if this is plus a number, then you're going up that many units on the graph. If this is minus a number, then you're going down that many units on your graph. So let me show you the little acronym that I was telling you about. So some of you are probably taking Spanish, and if you are taking Spanish, then this will be familiar to you. La, señor. So the word la, señor just means like the, which is the female the, and then señor is Mr. So you can think about like the Mr., I guess you can say. So la, señor. So la goes together and señor goes together. So what that means is when you are wanting to shift it to the left, you need to add a number to this inside here. When you're wanting to subtract, that means it's going to make it go to the right. So if you have a minus that amount, it's going to shift your entire graph to the right. If you are adding that amount, it's going to make it go to the left. So left goes with add and right goes with subtract. La, señor. And you can write this on your paper every time you're dealing with transformations, so you'll remember if it's shifting to the left or to the right. All right, so let's take a look at a couple different graphs. This is called the parent function. So think about your parents that you have. You're not a carbon copy of your parents, which means they didn't clone themselves and create you. You're a version of them in one way or another. So these four functions over here are a version of this parent function. This is the original one, and these four have been transformed in one way or another. So if you look here, this is where it's starting. This is the vertex that I was telling you about before. That's the point that's right there. So let me see if I can make a mark here. So right here, no, I guess it won't let me. Never mind. So right there is your vertex, which is at -3, -1. And you can see here that that's not at -3, -1 anymore. And this one's not at -3, -1 anymore. So these have been adjusted some way or another. So here, f of x, which is your y, plus 2. So they took the original function and they added 2 to the y value, which made it go up 2 places. So this was the original, now it's up 2 places. And then over here, they subtracted 1 from y. So instead of it being here, they made it go down to -2. So instead of it being at -1, now it's down to -2. However, look to see the difference here. They added a number inside the parentheses, so that's actually making it shift to the left or to the right. So remember, la, señor, well, adding goes with L, so that means it's going to the left, too. So it was at -3, over to the left 2, now it's at negative 5. So then over here, we are subtracting 1. Well, subtraction goes with right. So instead of it being at negative 3, now it's shifted over 1 to negative 2. So that's all you're doing. If it's outside of it and it's adding it or subtracting to the y, then it's going up or down. If it's inside your parentheses and you're adding or subtracting, that means it's going to the left or to the right. All right, so let's look at a table. So we have the table below shows the values for the function f of x. Complete the table for negative 1/2 of f of x. So here are your x values that you're going to use the table for when you're given these x values here. They're the same x values, they've just written it as a table on the right-hand side. And then here's your original or your parent function. These are the original f of x values. And we're trying to create a new function with negative 1/2 of that amount. So let me see if my little marker will work. Okay, we're up here. All right, so if we take negative 1/2, I don't know if it'll let me write. I want to do some text, insert text. Okay, perfect. All right, so when you take negative 2, it was 4. Well, in here now we have 4 times negative 1/2 in order to get our y, because that's up here. 4 times that amount, so I actually should write it negative 1/2 because that's first. So negative 1/2 times the 4, and I got my 4 from when x equals negative 2, so I just looked at the table and found out that it was 4. So negative 1/2 times 4 is negative 2. So when x equals negative 2, and then the new function, the y value will be negative 2. Then for this one, when x equals negative 1, y is going to equal 2. So again, we take our negative 1/2, we times it by 2 this time, and negative 1/2 times 2 is negative 1. And then we look for 0. Well, when x is 0, y is 0. So down here, we're going to take our negative 1/2, multiply it by 0, and anything times 0 is just 0, so that didn't change the value at all. And then when x equals 1, y is supposed to equal 2, but in our new function, we take negative 1/2, times it by 2. I should already know that answer because right here I have the answer. It's negative 1. And when x equals positive 2, we have negative 1/2 times positive 2. Oh, sorry, positive 2, it's going to equal 4. So negative 1/2 times 4, we already have that answer, negative 2. Now you're wondering, why do we have repeating answers? Well, that's because it's a parabola, so it's making that U shape. So the numbers on, once you go from this side, you would come back up the other side, or they're going to be the same y values because you're repeating the same y values. I don't know if it'll let me draw it, but I'll try, because I'm having a little issue with, okay, so here we go. So when you have your coordinate plane and your vertex is right here, the y values will be the same when you keep going across. So all of these y values from the left and right side of that U are going to be the same. So if this is 1, then this will be 1. If this is 2, then this will be 2. And this is 3, and this will be 3. So the y values will always be the same. The only thing changing is your x values, because this side of your vertex is a different x value than this side of your vertex. So you're just making that, it'll be symmetrical around the vertex. So in this one, you can see the lowest number that it goes to is 0 for the y value, which means that's the vertex. So your vertex for this function is 0, 0. And then it comes back up the left side, and it comes back up the right side. All right, and now take a look at this one. Let g of x equal f of x plus 3 minus 2. Graph g of x on the plane with f of x. Okay, so g of x is what we're going to create. F of x is this original function. So the first thing we have to do is we have to add 3 to that amount. So if we're adding 3, this will be shifting to the left by 3. So 1, 2, 3. That's our new, let's see if I can make this smaller. I'm just going to put a little point there so that we know that that's the vertex. So that's the new vertex shifted over 3. And then we're going to go down by 2. So we go down by 2 to this one. So here's our new starting point of that parabola. And I don't know if it'll let me draw. This might be interesting, guys. There we go. Okay. So the new vertex is going to look something like that. There we go. So I know there's a little space there. I can't do anything about it because I'm drawing blind, if that makes sense, because I can't see where I'm drawing. It's not showing my cursor. All right, so anyway, so when we shifted 3 over and 2 down, that's our new function. So you just use this information to move the left or right depending on what they're adding in here or subtracting, and then up or down depending on what they put here. And that would be our new function. So just want to go back to this page really quick, just so you know what happened here. So for this one, they are shifting up 2. For this one, because they are minus 1, down by 1. For underneath this graph, inside it's adding 2, so adding goes with left, so they went left by 2. Or 2 to the left, we'll say. And this one is minus 1. The subtraction goes with right, so we can go 1 to the right. So that's how you can tell, is just outside of the parentheses, that means it's the y. Inside the parentheses, that means that's the x that's moving left or right. So y goes up or down, and x goes left to right. All right, and that is, I believe, the last page. Let's see. Yep, go Seahawks.